Good evening, everyone. Today, we live in an era where ERP systems generates mountains of data. Yet many logistics and supply chain firms still struggle with the black box decision making. So I will be discussing our work on explainable customer lifetime value model today. While it's common to predict customer value through strategic optimization occurs when a customer value is explained with an integrated ERP and logistics framework. Our objective was to close the gap between human readable strategic trust and high performance machine learning as part of this research. Coming to literature review, we analyzed recent advancements in ERP-based enterprise applications as shown in table. Research has moved aggressively toward deep learning. If you see the table, June et al. And Ram et al. Demonstrates the power of CNN and hybrid models achieving high performance in classification and general analytics. As shown in Table SU 2024, enhanced ERP processing efficiency using graph neural networks, while Tahia et al. 2024 explored temporal feature learning using Deep CNN LSTM. However, we noticed a critical trend. While these models offer high performance, they often operate as black box or focus purely on repair metrics rather than long-term value optimization. Our research addresses this by introducing explainability via LIAM and dimensionality efficiency via sparse autoencoders, a combinations not fully explored in existing literatures. Coming to methodology, the foundation of any methodology like starts with the data and pre-processing. So for this study, we utilized the Brazilian e-commerce public dataset by OList. This is a rich real-world dataset covering thousands of orders and customer interactions. Before the modeling could occur, we performed rigorous data processing. This involved standardizing the data, handling missing values, and performing label encoding. But most importantly, it involved merging multiple relational tables to create a unified view of customer journey. As part of feature engineering, once the data was clean, we moved into RFM analysis phase. We calculated 3 core metrics for every customer. Recency, how long since their last purchase. So when they made their last purchase. Coming to frequency, how often customers buy any product. Monetary, how much total value and a customer bring. To turn these metrics into actionable insights, we applied K-mean clustering method by using the ELVO method and silo weight scores. We ensured that our customer segments were mathematically distinct and meaningful for business strategy. Coming to architecture, a key innovation in our workflow is to use the sparse autoencoder for dimensionality reduction rather than relying on traditional linear methods. The autoencoder allows us to compress the feature space while preserving the most nonlinear salient information. This step is crucial for reducing noise and improving the computational efficiency of our predictive models. With our optimized features, RayDB split the data into 80-20 train test ratio to ensure unbiased results. We propose 3 high-performance Ansible models, Random Forest, LightGBM, and XGBoost. To validate our predictions of customer lifetime value, we did not just look at the metrics. We used a comprehensive suite of performance measures, including MSE, RMSE, and R-square, to ensure our model was both accurate and robust across different customer segments. Coming to result analysis and discussion. Moving to our experimental results, we conducted a rigorous comparative analysis between our proposed approach and standard algorithms. As shown in table, our model achieved a benchmark setting of 95.64, which is particularly striking in is the error margin. For our RMSE was 39.7679, which outperformed models like LightGBM and XGBoost. Our MAE was 22.449, which ensures that the majority of customer lifetime predictions, the variance is minimal enough for automated ERP budget allocations. If we look at figure 2, the actual versus predicted plot shows a tight alignment, confirming high regression performance. Furthermore, the residuals versus predicted plot shows a random distribution around the 0 line, confirming our model does not suffer from systematic prediction bias. Moving to our empirical results, our comparative analysis confirms that the proposed XELB model sets a new performance benchmark for ERP integrated analytics. As detailed in table 3, our random forest-based approach achieved an R-square of 95.64, significantly outperforming traditional gradient boosting and decision tree models, which yielded R-square scores of 85% and 54.76% respectively. Beyond high fit accuracy, we achieved a low RMSE of 39.77 and an MAE of 22.48. In figure 2, which we have already earlier discussed, the actual versus predicted plot shows a tight alignment along the 45-degree diagonal, while our residual analysis demonstrates a random distribution around 0. This is critical as it statistically confirms the absence of noticeable prediction bias in our model. Now coming to innovation, this is the heart of our research. A high accuracy score is useless if a supply chain manager does not trust this model. We integrate LIME and residual analysis. By doing this, we take a single customer prediction and break it down. For instance, showing that a high CLV was driven by a frequency value in the 90th percentile, despite a recent drop in recency. This transparency transforms the model from a simple calculator into a strategic advisor, fostering trust between the AI and human decision makers. Coming to conclusion and future scope, in conclusion, the growth of e-commerce makes accurate and explainable customer value prediction a necessity for business success. Our work demonstrates that combining sparse autoencoders with RFM-based clustering effectively captures complex behavior patterns, providing an R-square of 95.64 with a strong predictive reliability. Looking ahead, we aim to expand this framework through real-time data integration and the deployment of advanced deep learning architecture such as transformers, LSTM, and GRUs within live ERP environments. Thank you for your time, and I am now happy to address your questions.